family to look at the GDP trends for the US and write down a markdown table of what it sees. We've given Opus and all the other models in the Claude 3 family extensive training on tool use, and one of the major tools it's using is this web view tool. It goes to a URL, looks at what's on the page, and because it's multimodal, it can use the information on that page to solve complex problems. So here's the markdown, and it's important to note that Claude doesn't have direct access to these numbers. It's literally looking at this same browser you and I are seeing, looking at the trend line, and trying to estimate what the exact numbers are. Let's see how accurate it was. We've asked the model to create a plot of the data, and it's used this second tool, this Python interpreter, to write out the code and then render the image for us to check. And here's the image. Look, it's actually added helpful little tooltip animations to explain some of the major peaks and troughs in the last decade or two of the US economy. And we can compare that graph with the actual data, and it turns out it's pretty close. It's actually within 5% accuracy. And by the way, Claude's transcription here isn't just coming from its pre-existing knowledge of US GDP. We tried it with a large sample of made-up GDP graphs, and its transcription accuracy was within 11% on average. Next, we asked the model to do some statistical analysis, projecting out into the future, performing simulations to see where the GDP of the US might head. And we can see that it's run this analysis using Python, and it's able to perform these Monte Carlo simulations to see what the range of GDP possibilities might look like for the next decade or so. But I wonder if we can go further. We're going to get the model to analyze a more complicated question, that is, how GDP might change across all of the biggest world economies, and then to help it do that, we're going to give it one more tool called Dispatch Subagents. This basically allows the model to break down the problem into lots of subproblems, and then write prompts for other versions of itself to help pick up the slack. The models can then complete a more complex task by all working together. Here you can see it's written this prompt and given very precise instructions that it wants the other models to follow, including a format for the data that it's hoping to return. It's dispatched a version of this prompt to one model that's going to look at the US, one for China, one for Germany, Japan, and so on. And we can see in these progress bars that the subagent models are now completing the set task for each of the individual economies. They're going to the relevant web pages, they're getting the information, they're running the code to analyze it, just like we saw in the previous US example, but all in parallel. Let's just skip forward to see what the model produced. You can see it's run the analysis, it's produced a pre and post pie chart of how it expects the world economy to look in 2030 versus 2020, and it's given us a written analysis too, where it makes verbal predictions that relate to the statistical analysis that it ran. It's telling us that it thinks the GDP share of particular economies will change, and which ones will be larger or smaller by 2030. So there we have it. Complex, multi-step, multimodal analysis run by a model that can create subagents to get even more tasks running in parallel. We're excited to see what you, our customers, can do with these advanced Claude 3 capabilities.